In lesson 7.3, we're going to be conducting a hypothesis test to see if there is a significant difference in standard deviations in two data sets. Suppose that we want to compare the consistency of two brands of golf balls, one being a less expensive brand and one being more expensive. We want to be able to predict how far the golf ball will travel when hit with as much precision as possible. Golf, as we know, is really a sport of precision more than power or force. And being able to hit a golf ball and know approximately where it's going to land is important in the sport. So, to investigate the precision of different types of golf balls, an experienced golfer hit 10 of each brand of ball in random order using the same club. And the results of that experiment are shown in the table. So, notice what we're showing here is the drive distance for each type of golf ball. Now, it could be that one type of golf ball is, in fact, more consistent than the other, or the difference and the variability that occurs in those distances could just be due to random chance. To determine which is the case, we're going to test for a difference in standard deviations. Now, when we're doing a test for a difference in standard deviations, this is how we'll write our hypotheses. The null hypothesis is going to be that the true standard deviation of the cheap golf balls is equal to the standard deviation of the expensive golf balls. Remember that typically when we write a null hypothesis, we're assuming that there is no difference in whatever two cases we're looking at. Now, what we're testing for is a difference in consistency. And remember that if something is more consistent, that means that it has a smaller standard deviation, or less consistent means that it has a larger standard deviation. So in this case, our alternative will be that the true standard deviation of the cheap golf balls is greater than the standard deviation of the expensive golf balls. We believe that the cheap golf balls are less consistent. And again, that means therefore they have a greater standard deviation. Now we're going to calculate the test statistic. So the way that we're going to do that is go back to the data that was presented at the beginning of the notes. And what I would do is I would put the cheap golf balls into list number 1 and the expensive golf balls into list number 2, and then do the one variable stats calculation on your graphing calculator to come up with the standard deviations. So the standard deviation for the cheap golf ball is about 8.5. The standard deviation for the expensive golf ball is in fact smaller. That's about 4.8. And we're testing for a difference in standard deviations. So our test statistic then will be the difference of those two values, which would give us a difference in standard deviations of 3.7. Now, in your notes, you're provided with a dot plot, which shows 100 results from 100 simulations. If the experiment were conducted, assuming that there is no difference in the consistency of the golf balls. And again, remember, no difference in consistency means that the difference would be 0. So this point right here represents that the golf balls are equal in consistency. And then we have some where we have a negative difference, which would actually mean that the cheap balls are more consistent than the expensive golf balls. And then we have on the positive side the cases where the other side of that is true, where the expensive golf balls are more consistent. Our test statistic was 3.7, and you can see that there's a dotted line drawn in here in your notes indicating where that 3.7 is on the scale. And so to get our p-value then, we would look for all of the simulations that resulted in a value of 3.7 or more extreme, which in this case would be greater than, and we only had 2 simulations out of the 100 that were conducted. So 2 out of 100 gives us a p-value of 2%. So that difference is not likely to happen by random chance. Therefore, our conclusion would be to reject our null hypothesis. That tells us that there is good evidence that the cheap golf balls are less consistent than the more expensive golf balls. Please do assignment 7.3 in your homework packet.